Okay, this is now the second part of the question 1. We are basically given a formula: x of t is equal to some constant times an exponent of certain things times the sine of something else. Remember that we had the standard equation with the mass, the spring, and the damper, and we worked out the equivalent mass, the equivalent damper, and the equivalent spring constant. We're basically saying when it's undamped, when zeta is less than 1, that is the formula for the equation, and we've already previously worked out zeta and omega n. So these are known values, and c is an unknown, phi is an unknown, and the question is basically asking you, please solve for c and phi in terms of the available information. What is the available information? We are given that at time t is equal to 0, the initial velocity is x0 over there, and the initial time derivative at time t is equal to 0 is x dot 0. So this x dot 0 is known, and the x0 is also known. So how do we work out c and phi? Basically, we've given the expression for x, work out the derivative for x dot. So x dot is basically the derivative of x, and we apply some formulas with the chain rule. So basically, remember your first year calculus. If you have a function as a product of two other functions, f and a g, then the derivative of that would be the first one's derivative times the second function plus the first function times the second derivative. So c is a constant. We have this exponent thing, that's a function. We have the sine thing, that's a function. These are basically two functions. We apply the standard chain rule and derivative rules. We work out an expression for x dot. That's basically the velocity. Then, having done the calculations, make the observation as follows. I have 3 lines of calculations. I have a line for the original expression. I have an expression for the second calculation and a third calculation. So basically, if the derivative is 3 marks, take 3 lines to do the calculations, and then you'll get the full marks so you don't lose anything. So put in time t is equal to 0. When x of t is that expression, and when t is equal to 0, what happens? Okay, t is equal to 0. I have an exponent of 0, which will basically 1. I have sine of something plus something else. Omega d times t 0, that'll be 0. So I'm left with a phi. And then I have the phi over there. Likewise with the expression with the velocity, I put in t is equal to 0. Omega d is already known. We worked out omega d is equal to omega n square root 1 minus zeta squared, which is, let's just put this down somewhere on the side. Omega d is equal to omega n square root 1 minus zeta squared. We have that expression. We've previously worked that out. So what happens at the end of the day? We have 2 equations in terms of the 2 unknowns. We've got an equation 1 in terms of c and phi is equal to something known, and equation 2 in terms of c and phi. Omega d is already known because we've already worked it out over here. We know omega n and omega zeta over there, so we already know what omega d is. So what do? We have these 2 equations with 2 unknowns. We solve it simultaneously, and we'll do that in the next video.